time when it came out. So when the book came out, there was a bit of a rumble around about this really good book and actually being quite scientifically correct and accurate and interesting, but also being a really good potential film. And then it was turned into a film quite quickly afterwards, which is quite unusual. Now, the person who wrote it was Michael Crichton, and Michael Crichton has a history of writing scientifically focused books. And he actually did a degree in biological anthropology, so the biology of human evolution. He switched from English at Harvard to biological anthropology and then completed his studies as a medical doctor, but never actually worked as a medical doctor. That happens quite regularly. He did that. Now, interestingly, the reason he swapped out of English was because of this. He felt that his work was being unfairly marked. So he, in cahoots with some of the other professors at Harvard, he decided to hand in an essay by George Orwell, and it was graded as a B-, and he realised he was being treated unfairly, so he skipped quickly out of English and did the right thing and ended up in the biology department. Okay? So quite an interesting story. He's a fascinating character, and his books are very tight, and he was very sort of enjoyed the fact that he got the biology as correct as possible. But then you hit this issue around a story versus science, and do they clash with each other, and you might not get the story that you want. So Spielberg picked this book up, and that's a big thing. Having Spielberg making your film is great. The problem is that Spielberg has real control over the films that he makes, and therefore he wanted the film to run in a certain way and had to change some of the book. So the book isn't as accurate. The film isn't a full accurate depiction of what's in the book. There are some changes that were put in there to change the characters slightly and some of the other areas. So basically the premise of the film is that the billionaire John Hammond, played by David Attenborough's brother Richard Attenborough, which is quite an interesting thing to do. Think David Attenborough's brother to play a character in a film. He decides that he wants to bring dinosaurs back into the real world using their DNA. And to make the part credible, he invites a number of scientists, one of whom is a dinosaur expert, two dinosaur experts, and one is a chaos theory expert, and we'll talk about chaos theory in a few minutes, to come and have an early tour of the park and see it in action. And then the hope is they would go back and report on it and build up a fan base for the park so people would want to come and visit. Does that make sense? The problem is that another company decides that they want to get hold of the dinosaurs and produce their own Jurassic Park and steal the technology, and they pay off one of the people working there, and the way that he then steals the technology is he has to shut down the security in the park, which lets all the dinosaurs out. You can see where this is going. And the scientists are on their tour of the park when the dinosaurs get out, and they have to fight for their survival. So it's a cautionary story about the ethics of genetic engineering. It's really about, should you bring animals back from the past, and we'll talk about that in a bit more detail. But there is, certainly the book is much darker, it's certainly more violent, and there's a slightly different start and end to it. But I would say the film's pretty decent in terms of a depiction of the book. But I quite like reading a book and then watching the film. I think you get two very different views of it. I think really like that as a way of doing things. So it's not unusual. I always read the book first because I can get lazy if I watch the film. So I always read the book first, then I watch the film. I couldn't do that so easily with Jurassic Park because there was a rumbling about it. I didn't get a chance to read it up to that point. Okay, this is my favourite line from Jurassic Park. So Dr. Ian Marshall, Chaos Theory, I'll mention it later. He's in discussion about Jurassic Park, and he comes up with the famous line, your scientists, you should say, your scientists were so preoccupied with whether or not you could, you didn't stop to think if you should. And I use this all the time when I'm talking about genetic engineering to my students.
Frankenstein,
okay, Frankenstein line. Okay, there you go. Because you might be able to do something, but is it the right thing as a scientist to do? And so he used this line from Frankenstein in his conversation. Okay, so let's go through the sort of science of it now and have a poke at it. So it's all to do with the idea of how DNA works in genetic engineering, and there's some fantastic little Easter eggs, as they're called, through the film. So at one stage the light comes through a ceiling tile like these onto the dinosaur, and if you pause it you'll see that the actual shadow is really genetic code written across the dinosaur. You wouldn't see it in a cinema at top speed unless you pause it and someone points it out to you. There are little things like that all the way through the film as a nod towards the genetics of it. Okay, so this here I'm going to show you is a quick clip, And this is actually from Jurassic Park, where they're explaining to everybody how they brought the dinosaurs back, and then we'll look at that as a sort of science, and we'll show you that. There may be an advert, and I have no idea what's going to turn up, but we'll find out in a second. So hopefully it'll be about flowers, but we'll find out. Oh.
It's about flowers.
I know YouTube too well.
How did you know?
Poltroni Sofa is here with special introductory prices.
Sofas. They get flowers for sofas. It's been alright with one.
Now just $6.99. The comfy and stylish Rosetta, just $8.99.
This should be...
And Mileto, double power recliner, in real leather with table and power charger, just $9.99. Plus, up to 5 years interest-free credit on many sofas.
Ciao.
Were
Welcome
you
to
enjoying the
Poltroni
sofa advert
Quality
before the
sofas.
tour?
Italian touch.
Skip,
Exclusively at...
Why don't you all sit down? Donald, sit down. Right, here he comes. Well, here I come. Yes. Hello. Hello. Say hello. Say hello.
Hello.
Hello, John.
Oh, yes. I've got lines here.
Well, fine, I guess. But how did I get here?
Well, let me show you. First, I'll need a drop of blood. Your blood.
Right. Oh, John, that hurt.
Relax, John. It's all part of the miracle of cloning.
Hello, John. Hello, John. Hello.
Hello, John. From what?
Hello, John.
Blood extraction has never recreated an intact DNA strand.
Not without master sequence gaps.
Good afternoon,
Alien
John.
DNA from what source? Where do you get 100 million year old dinosaur blood?
Shh.
What? Oh, Mr. DNA, where did you come from? From your blood. Just one drop of your blood contains billions of strands of DNA, the building blocks of life. A DNA strand, like me, is a blueprint for building a living thing. And sometimes animals that went extinct millions of years ago, like dinosaurs, left their blueprints behind for us to find. We just had to know where to look. 100 million years ago, there were mosquitoes, just like today. And just like today, they fed on the blood of animals, even dinosaurs. Sometimes, after biting a dinosaur, the mosquito would land on the branch of a tree and get stuck in the sap. After a long time, the tree sap would get hard and become fossilized, just like a dinosaur bone, preserving the mosquito inside. This fossilized tree sap, which we call amber, waited for millions of years with the mosquito inside until Jurassic Park scientists came along. Using sophisticated techniques, they extract the preserved blood from the mosquito and, bingo, dino DNA. A full DNA strand contains 3 billion genetic codes. If we looked at screens like these once a second for 8 hours a day, it'd take 2 years to look at the entire DNA strand. It's that long. It's full of holes. Now that's where our geneticists take over. Thinking machine supercomputers and gene sequencers break down the strand in minutes. And virtual reality displays show our geneticists the gaps in the DNA sequence. We use the complete DNA of a frog to fill in the holes and complete the code. And now we can make a baby dinosaur. This score is only temporary. It all has very dramatic music, of course.
Okay, so let's crack into some science of Jurassic Park. So I've just put up on here 3 of my most favourite fossils that you can find. Do you know what this is called? Go for it.
Is that pterodactyl?
It's not, but it's a flying dinosaur. You're absolutely right. Okay, this is Archaeopteryx, which is the most famous dinosaur fossil probably in the world. It's held by the Natural History Museum. It's found in Germany. And actually lots of money chased hands and all sorts of dodgy deals were done to get hold of it. And it has feathers. So it's a link dinosaur between the dinosaurs and the birds. So dinosaurs turn into birds. And in fact, they use this to say that dinosaurs had bird-like behaviour, and they used that when they made the film. Obviously, we've got a scorpion here, and these are some of my favourite footprints. These are actually the Tony footprints. They are fossilised human footprints. They're 2 sets of footprints walking next to each other like this on volcanic ash, and they actually froze into making footprints. If you laser scan them, you'll actually find the footprints of a child in them, and that child, we don't know if it was following its parents and hiding its footsteps, or if it was playing. And that's the point of Jurassic Park, is that we can't tell the behaviour of anything from its fossils. So we will never know how dinosaurs behave very well until we bring them back. To get the idea? So the idea about Jurassic Park was to try and see the behaviour of the dinosaurs rather than just the structures of them. All happy so far? Okay, so we can sequence genes very quickly now. You can do a human gene sequence in probably a couple of hours. You can get the whole of a gene sequence, and we can also make DNA as well. So we can make DNA sequences with a gene machine pretty easy. But there's a problem. Can you extract DNA from fossils? And the answer to that is not really. So DNA has what we call a half-life. It breaks down, half it breaks down every 521 years. And dinosaurs died out 65 million years ago, so that means we've had 125,000 half-lives. Half the DNA is broken down, another half of that half, another half of that half. Do you get the idea? It's hardly any DNA left. We can detect DNA, but it's not readable. So it's almost like having a book that's been ripped up, and we'd never rip a book up, ripped up, and it's happened 125,000 times. You've ripped that book in half, and then you're trying to read it. Do you get the idea? So it's going to be extremely difficult. It doesn't mean we can't read DNA from fossils. Sorry, I should have pointed this out. This is why dinosaurs died out. You're probably aware that a massive meteorite hit Mexico. We now know what happened to them. We can get hold of DNA. So this is one of our human ancestors. This is a Neanderthal. And Neanderthals only died out 30,000 years ago. So maybe, what we're talking there, sort of 40 lifetimes ago, 50 lifetimes ago, not that long ago. And we have been able to extract DNA from these fossils. We've got about 60% of Neanderthals' DNA, and you and I carry about 1 to 4% of that. We can actually analyse it. So something that's quite recent we can get DNA from, but from dinosaurs it's going to be extremely difficult. See the first hole in Jurassic Park. Okay, we can get DNA from frozen mammals and frozen animals. This is a frozen baby mammoth that was discovered in Siberia, and because it was frozen, the DNA stays in better condition. But the question is, should we bring them back? And that's one thing you need to ask yourself. Do we have a responsibility or a right to bring back animals that have become naturally extinct? It's an ethical question, isn't it? If they become extinct, there's probably a reason for it. But again, fossils don't show behaviour, so by bringing them back, we can try to work out this very well-known question of nature versus nurture. Is your behaviour due to your genes, or is it to do with the way you're brought up? Yeah? And by bringing these back, we would have an idea of how much behaviour they have built into themselves. You get the idea? So that's part of Jurassic Park. Okay, the big issue for Jurassic Park was that all the dinosaurs were made female to stop them reproducing. You get the idea? So they made all the dinosaurs female with the idea that they escaped off the island, and there are a number of fail-safes in the book that they would never be able to breed. But they made a mistake. And one of the mistakes is that when you use amphibian and reptile DNA, some of their sex is controlled by chromosomes, and some is controlled by the temperature in which the egg actually develops, basically. And so if you have a change in temperature, you can actually change the sex. And by putting bullfrog DNA into the dinosaurs, when they have, and some reptiles will lay eggs without mating, they will change into males and females. You get the idea? And suddenly they discovered male dinosaurs on the island. They started to lose control of the island. You get the idea? So it all became quite messy. Now this is quite worrying, temperature changes, because, as we know, we are worried about rising temperatures actually killing off reptiles around the world, because if the world gets too warm, you'll end up with loads of male reptiles being born. So turtles are a good example of that. We are worried that beaches get warmer, the eggs will turn to males, and there'll be fewer females to breed, and global warming could actually wipe them out. Okay, so it is an effect of 1 or 2 degrees could cause some real problems. So there's a problem there for Jurassic Park. Just to ruin another film for you, Finding Nemo. Okay, have you all seen Finding Nemo? Yeah. Okay, yeah. So his dad and Nemo obviously lost his mum. Mm-hmm. In reef fish, if the female in the pair dies, the male turns into the female. Oh, okay, they change sex. So Finding Nemo would never have been brought up by his dad at any stage, because his dad would have turned to his mum. Okay, it happens all of the time. So the reason I put this up here is that we need to stop anthropomorphizing, okay? And Jurassic Park is based on this idea of trying to give human characteristics to organisms. The dinosaurs, some of them are trying to be made to be almost like human villains. Do you get the idea? Okay, and it's very easy to trick humans in films to think, the audience to think like everything's human. Yeah, there's ways that you can do it. So one of the ways that you do that is you work on ratios. You have small eyes and small nose and big heads and big feet. They look like babies, human babies, and you immediately like cartoons like this because they elicit a reflex in you. It's a baby. Do you get the idea? And so when they came up with the dinosaurs, they decided they needed something that was about human height, with beady eyes, a bit of a smile going on. Do you get the idea? Okay. So this dinosaur here doesn't exist in the real world. It was made up for Jurassic Park to become almost like a human villain. Make sense? Yeah. Now it is based on a real dinosaur. It's based on Dionysus. But actually, I'll come back to feathers in a minute. But Dionysus is not a very good anthropomorphic dinosaur because it's too small. Do you get the idea? So they scaled it up. But they hit jackpot. Spielberg couldn't believe it because a dinosaur had been found in 1931 and the fossils had been hidden away in the back of a university. It happens all of the time. And in 1991, a scientist found these fossils and described them and drew up what they thought that fossil would look like, and it's called a Utah raptor, and they found a human-sized raptor, and it gave credibility to Spielberg's film. Does that make sense? And you'll notice the toes here. Okay, those who've seen Jurassic Park, they couldn't believe their luck that they'd started filming and this dinosaur was found. Do you get the idea? Okay, because it anthropomorphized for them. Okay, so they got away with it for that one. Okay, the other thing they made a mistake with is we now know that dinosaurs are often feathered. Okay, they have feathers. T-Rex had feathers. Utah raptors had feathers. So this is a very feathered dinosaur. You can see that down there. In Jurassic Park, all of the dinosaurs were brown and green with scales, weren't they? Okay, if you've seen it. But actually, most of them would have been feathered. Here's another fossil. You can see feathers down its tail here. The question is, why were they feathered? Well, I'll come back to that in a second. But we can't tell the colour of dinosaur skin because dinosaur skin does not fossilise. So I can't tell you if dinosaurs were brown, green, whatever colour they were. But with the feathers, we can tell the difference because we get these little crystals in feathers that refract light, and you can see the colour. So we actually do know the colour of dinosaur feathers because those little crystals and minerals can be found in the fossils. You can reflect light at them, and you can work out what colour the fossils were. Yeah, okay, but we don't know the skin. The skin is made up. Okay, so they have these photonic crystals in them that give them feathered colour. So why do they have feathers? Well, a couple of reasons. They first of all started to be used to be warm. Have you all heard that dinosaurs are cold-blooded? Not really. I'll show you why. Okay, so if you look at the blood vessels of a dinosaur, they started off. Now, the thing with dinosaurs, they were around for 80 million years, 100 million years, however long they're around for. So we can't think of all dinosaurs being in the same place at the same time. We had very early dinosaurs and we had much later dinosaurs. The early ones were very much cold-blooded, but as they developed, they started to become warm-blooded. And the reason we know that is if we look at the blood vessels in their arms and legs, in the early dinosaurs, they ran very much apart. So the warm blood would come down to their claws, paws, whatever you want to call them. I've got a zoology degree, slightly concerning myself now. So the warm blood would go down to here, and then it would come back up here, and the cold blood would come up here. Does that make sense? Now the problem with that is you lose loads of heat from here. Over time, those blood vessels move next to each other, and you can see the holes in the bones. And the idea is as the cold blood came back up here, it would take the heat from the warm blood vessel before it got to the hands. It's why your hands are colder than your body. Do you get the idea? Because you're trying to conserve heat. So the dinosaurs, we can actually see these blood vessels, so we know that dinosaurs started to become warm-blooded. Does that make sense, everybody? Okay. So the feathers would have helped them thermoregulate. It's also to do with sexual dimorphism and species identification. So these are mallard ducks. Yep. That is a really dull brown duck, and the reason it's brown is because it can sit on eggs and you can't see it. Do you get the idea? Mm-hmm. But how does that duck know that that's the same species? And if you ever have a look, when they lift their little brown wing up, they have a little coloured bar under here that says, I'm a female mallard. I'll hide it again now because I don't want to be eaten on my nest. Do you get the idea? And it means that this male mallard doesn't go around sort of chatting up swans or chatting up mandarin ducks or whatever it might be. It can tell its species. So one of the reasons why you have that is that the dinosaurs could tell which other dinosaurs were its species and which were males and females. Do you get the idea? Yeah. The other thing that's really interesting is this, what's called the Hamilton and Zook hypothesis, which is the idea is that this reduces your chances of surviving. So if you're still alive and you're dragging this around, you must be really, really strong. Get the idea? And also, this will be destroyed by parasites and horrible diseases, so you must have a really good immune system if you can keep this alive and in really good condition. Do you get the idea? So in other words, if you mate with a male like this, it's going to be strong and have a really strong immune system. That makes it a really good male to mate with. Do you get the idea of feathers, everybody? Okay, and so that's why peacocks have ended up designing this. It's a bit anti-Darwin for those who've done GCSE, because it should be helping you survive. It's also the reason why people go, I drank 10 pints last night and I'm still here today, because they've just poisoned themselves and they're trying to show off their strength. Self-harm hypothesis. Okay. Also a bit of camouflage, also protecting eggs. So we know that dinosaurs, many of them were feathered for lots of reasons. Okay.
Can I just ask about the peacock then?
Yeah, go on.
Because they're originally from India, aren't they? India's got tigers. Is it not a
different area though, isn't it? So they're geographically isolated.
Okay.
So
there's got no predators then, is that right?
There will be predators, but they'll peck at them and they'll fly and do whatever behavioural things they do. But this reduces their chance of survival. So if they get to adulthood, they are strong and they are good. Right. So it's the opposite almost of Darwin, of things help you survive. They're helping their genes survive by showing off. We also think it's why people have tattoos. Yeah, it's why. Have you ever seen rugby players who, particularly from New Zealand, who are covered in tattoos? And what happens is they are tattooed until the point they pass out. So they cut. You know about this more than you've got in New Zealand. So the idea is you're tattooed and tattooed and tattooed, and you keep being tattooed until you pass out. So the more tattooed you are, the stronger you are. Do you get the idea? So people want to be absolutely covered, and you're showing it. And also, the more cut you are, the more risk of infection you are. So if you survive that process, you've got to have a strong immune system. So you become more attractive by being tattooed. There's the reason for it. Okay, so they also built in a couple of other bits and pieces, which is quite interesting. So they brought in something called the lysine contingency, which is the idea that the dinosaurs must eat an amino acid called lysine. And if they don't get it, they will die. And the idea, again, is if they get off the island, they won't survive. Do you get the idea? Mm-hmm. But the problem is, they hadn't sort of worked out the fact there was lots of other living things on the island that the dinosaur would eat, including all the other dinosaurs on the island if they got out their enclosures, and this was just not going to help them at all. So they brought that into. Okay. And Dr. Marshall talks about the fact that life will find a way, chaos theory. Life will find a way to get over all the obstacles you put in front of it. And that's part of the film. I won't show the video because of time. So he talks about the fact that tyrannosaurs don't obey set patterns on park schedules. Their essence is chaos. They want to get away and they want to survive. And he says it simply deals with unpredictable and complex systems. The shorthand is the butterfly effect. The idea that me talking today here might move some air that might affect the weather, that could actually have really big concepts. And Jean's going, I thought you'd like to run off then. Are you okay?
No, it's because we did this. We did something about the butterfly effect in English at the beginning of the year.
Did you?
About
okay.
dinosaurs.
Dinosaurs. Okay. So yeah, the idea. So the butterfly effect is the idea that everything we do could have. I could say something today that's tiny that could start you off on a journey that ends somewhere that you have no idea you're going to go to. You get the idea? And that is chaos theory. And chaos theory is trying to find within complicated patterns. Can you see a pattern? And Dr. Marshall's view is chaos, in the end, the dinosaurs will find a way to escape the park, and what they're doing is really silly. They should not be going. If they've been wiped out once, why bring them back now? Trying to contain animals that are very good at surviving, they're going to find a way. And that's the premise of it. Go on.
Was Jurassic Park also made as a movie or made as a book to bring awareness to this and to say, almost give a hint to scientists not to bring it back? Yeah,
very much. It's very much about the danger. So 1990, a long time ago for you, was really the start of genetic engineering and really being able to scan DNA. And Michael Crichton was like, where could this go? And one of the problems we have now is that we can scan DNA so quickly and we can change DNA. We can now go in and change genes. You could, in theory, design children. You're so preoccupied with if you could, you didn't stop to think if you should. And so this was a warning about where this could go to. Absolutely. He saw some of the dangers of it. Yeah, go for it.
Is that what happened to the koala?
did do that when extinct, and then they apparently tried to bring it back, and it went extinct the second time.
So there are some animals that have got, if you don't change the habitat, if you've got nowhere to live, then once you're extinct, you're gone. And so that's the problem, is there's no point, to be honest, the biggest hole in the whole of Jurassic Park is what are you going to feed them? Because the plants alive today have got defence systems that weren't around 65 million years ago, and the dinosaurs wouldn't cope with that. So if you change an environment and an animal gets extinct and you bring that animal back and the environment is the same, you're going to lose it, which is why we're losing things like polar bears, because the environment's disappearing. So there are lots of holes in this, but it is meant to be a bit of fun at the same time. Okay, so is it accurate? It's sort of yes and no. And I would argue it doesn't really matter. Okay, my interest in dinosaurs, my interest in lots of things was slightly sparked by it. There are lots of young people who have gone on and been sparked by Jurassic Park. The holes in it don't really matter as long as you discuss them. But it's an awesome book to get people interested in the past. And dinosaurs, I find them mind-blowing. Can't get it. Find it really hard to understand that these things were around here, romping around the place. So in a way, I don't think it really matters if it's scientifically correct. But I think it's really interesting, and I think it gets us to think really about genetic engineering and should we do things. And I think that's really important. And for me, as a sort of humanist, I love the fact that people are all different and the world is a really different place and it's really, really varied. I think that's the biggest joy. And my biggest fear for me is not bringing back dinosaurs, but starting to engineer people to get them to be similar, or from a sort of mailing list, if that makes sense. And I think that's the warning that they're trying to give. It's not really about bringing animals back, it's about where could genetic engineering end up if we don't ask that really important question of should we? Just because we can doesn't mean we should. And there's lots of things that we can do in genetics now which we're not allowed to do. Okay, there are laws in place to stop that happening, but we live in a world with 167 different countries, whatever, which all have different rules. So we almost need to internationally agree what's okay, because I might not be able to engineer my child here, but I might be able to go to another country and do it. So we want all scientists to be thinking in the same way about should we be doing this stuff. And I think that's the biggest warning from that book, is about where can genetic engineering take us. Is that okay? Give you a few ideas? I think time-wise that's probably all right, isn't it?
That's great.
Is that okay?
Thank you. Yeah, brilliant.
Any questions?
Any questions, girls?
Had a long day at school. But definitely read it if you get a chance, and if you haven't seen it, do. The later films are definitely, the first one is by far and away the best. I mean, they are good. The more recent ones are really good, they're really clever, but they're not playing on the scientific reason for that book. They are there as much more of an adventure book. But it's really good, and it stands up. I know a little bit of it's dated, but it does stand up to the test of time pretty well. Go for it.
Wouldn't the dinosaurs at Jurassic Park, wouldn't their genes be copied and evolved to suit to the environment again?
Yeah, absolutely. Yeah, so the problem you've got is it's time. So evolution takes a long time. So evolution is really... So there are two theories in evolution. One is that things drift very slowly over time. And the other theory is what we call punctuated evolution, the idea that you get big steps and big steps. So the human brain pretty much doubled in size because of one single genetic fault. So that's a really big increase in stuff. The problem the dinosaurs have is they've got to, even if they're finding the environment challenging and they can get through that and reproduce, it'll be okay, but the environment's going to be so challenging they're not going to survive to reproduce, and that's going to wipe all of them out. If they'd managed to make the environment just that bit of challenge, then they could have had children, they could have survived through it, if that makes sense.
Did they make water dinosaurs?
Did they make all of them?
Water dinosaurs.
No, they did in later films. So they wouldn't have done it because they were worried about them. So this was set intentionally on an island. It's off the whole...
I think it's Costa Rica.
Costa Rica, something like that. And they intentionally put them on an island to contain them. They were really worried, which is actually where the book differs quite considerably at the start, because they're not contained even at the start of the film. And the idea is they didn't want to put anything in the water because the containment would have gone. So they did actually have then in later films, and they didn't make any pterosaurs as well because that would have been hard to contain. So in the later films, they did have pterosaur sort of enclosures. But guess what happens?
Because my favourite dinosaurs they're all water dinosaurs. I like ichthyosaurs, pliosaurs, plesiosaurs.
Well, Mary Anning, obviously, the famous dinosaur expert. Mary Anning, isn't it? Mary Anning, isn't it? Yeah, found them, and she did most of that pliosaur sort of work as well. And of course,
ichthyosaur as well. She discovered ichthyosaurs.
And there's just stacks of them. If you ever get a chance to go down sort of to the Jurassic Coast, you can find lots and lots of stuff down there. It's great to go and have a day out, sort of whacking rocks and finding stuff. Anything else? Any other questions?
Of course, Crichton wasn't the first. I mean, Conan Doyle had written A Lost World, hadn't he, as well? When they're all on top of a volcano, extinct volcano, aren't they?
They annoy me because they've got cavemen in. Right, a caveman do my head in.
I agree, it's not accurate.
Yeah, so the problem I have as a science teacher is that we pick loads of information up and we can't remember what's right or wrong, and it drifts into our sort of understanding. So those who've talked before, I love scientific mistruths. You know, the idea that carrots help you see at night, or spinach contains loads of iron, all this sort of stuff, and you spend your life trying to fight generations of mistruths that go through. And when you talk about cavemen, it completely forgets about cave women. You think cavemen without cave women, so I was going to call them cave people. And when you talk about sort of people who, they didn't often live in caves, most of them came out of Africa, and that's an amazing part of our history. But human evolution, humans have been evolving from our early sort of primate ancestors for about 4 or 5 million years. We can find sort of human ancestors. Dinosaurs 65 million years ago. We weren't anywhere near the dinosaurs. So as soon as you have a cave person and a dinosaur in the same room, it messes up. And you start thinking that people were hunting with spears and hunting dinosaurs, and it messes up our timescales a bit, and that causes a few problems. So, yeah, you get those great films, but they do cause a few problems because then you have to teach out timescales. It's really hard to do it. Anything else? Get into human evolution, though, is awesome. If you get a chance to look at our human ancestors, it should be in the syllabus. I want to know where I came from. I want to know that stuff. I find it amazing. So I love dinosaurs, but nobody's yet done something brilliant about humans, and humans are really cool. If you get to have a look at the fact that 30,000 years ago there were 2 species of human on this planet. We lived with another species of human at the same time. That is mind-blowing.
You need to read the last but one, William Boyd.
Okay.
Because that's about a Neanderthal boy.
Yeah.
I can't remember I read it really quickly, but you know how they've discovered that the Neanderthals died on the peninsula of Iberian Peninsula. The arc of the story is effectively that he can't cope and he's being hounded by geneticists, etc. And so that's where he ends up. But Boyd does a really good job of picturing a man who's quite different from Homo sapiens and what happens to him.
And living in a modern society.
Living in a modern society,
really? Okay.
Yeah.
Because the interesting about Neanderthals is that we don't know what wiped them out. We think it's competition. We think it's probably because they had bigger brains, they were stronger. We think it's cooperation. It's that one of the reasons why you're here is we're vertically transmitting information to you from one generation to another. So your voice is incredibly strong, and you transmit information to each other, and you learn from that all the time. So as we talk, you're learning. And we think that the Neanderthals didn't have as good voice boxes, or their brain was not as well set up for delivering sound. So their vocabulary would have been more limited, and their transfer of information would have been worse, potentially. And we also think we out-traded them. Humans became very, very good at trading. And so you can then, if all of you over here make spears, and you all make clothes, and you all make stuff, you become very effective, and you trade, and suddenly you become a very efficient population. And Neanderthals may have not specialised in that way because of speech and the way their society was set up, and actually it was actually an efficiency issue, an energy issue. They just had fewer children, so they were less efficient. Very complicated to know why they disappeared. You've not expressed, sorry.
The evolution of humans, not just from the past but into the future, is what I find very interesting. Like how will humans adapt to the future and the environment that we're going to be getting into. And I specifically think of in certain scenarios, like if humans had a more watery habitat, how we would adapt, and especially with climate change, we're going to be getting higher sea level rise, but also the temperature's going to be getting higher. So I like to think about how we would adapt.
I'll chuck something into that for you to think about. Yeah. Our evolution will be incredibly slow if we evolve at all. And the reason for that is that people who would not have survived will survive because of medical intervention and have children. So therefore natural selection is not as effective. Evolution is powered by the environment. Most of us live in artificial environments. So what's actually likely to happen is our environment will continue to be manipulated to make it more comfortable for me to survive. So if we go into water, we will take an artificial environment into water with us, a submarine, rather than us get used to it. I think the thing that might power evolution in us a little bit will be unseen. It will be diseases. So we have some natural genes that make people fully immune to HIV. We have people who are more immune to COVID and things like that. So I think that's more likely to drive our evolution than anything else. And I think because people are moving all over the world so much, I think what we'll end up with is more people mixing genes and actually ending up what we call hybrid vigor, that strength that people from different... so if you look at Brazil, it has the best genetic health of any country because the people in Brazil come from Spain, Africa, everywhere else, and you get that real mixing of genes and actually causes real health. So I think as people are stepping away more from being in relationships with people from their own genetic, cultural backgrounds, and that's becoming more common, I think that will actually be a real positive for humans. So we might not actually see it, but I think we'll just strengthen up our genetics over time. Which will be really interesting. Anything else? Probably enough genetics for 4 o'clock in the afternoon. Is that okay, everybody?
Thank you, Mr.
Yeah.
Owen.
Thank you.
Really
Thank you,
great.
Mr. Owen. Thank you.